a problem from tangential and normal acceleration. And the problem says that a point moves in a plane car so that its tangential acceleration is constant. Right? It is given that the tangential acceleration is constant. Right? And the magnitude of tangential velocity and normal acceleration are in a constant ratio. This is the second condition. These two are in constant ratio. So that the intrinsic equation of the car is S, which is given by this. Okay. Now we first try to draw a rough sketch of intrinsic coordinate system. Okay. We first draw, this is x-axis and this is y-axis. This is the Cartesian coordinate axis, x-axis, y-axis. This is origin, and let it be the given curve. Okay, and let A, this is the initial point from which the arc length is measured, and let P be any point on the curve at where we draw a tangent. Okay, and now let this tangent makes angle psi with positive direction of x-axis, and AP with the arc from A to P, this is denoted by S, right? Then the relation between S and psi is said to be the intrinsic equation of the curve. We have to find this intrinsic equation. Okay. Now understand about this three terms. This is tangential acceleration, this is tangential velocity, and this is normal acceleration. Okay. And we already draw a tangent. Now we draw here a normal. Okay. This is perpendicular to the tangent. Now tangential velocity acts along the tangent and it is denoted by Vt, and normal velocity is Vl along the normal. Okay, and tangential acceleration, which is given by Vf, and normal acceleration, which is given by Fn, and this is not Vf, this is Ft, tangential velocity. Okay, tangential acceleration. F is denoted by acceleration. Now we already write here the value of this four quantity we use here. Okay, we know that the tangential velocity is V, generally V, or it is also given by ds dt. Okay, and this is V or ds dt we write here, and normal velocity is 0. This is 0, and the tangential acceleration is denoted by dv dt. Okay, or we write this is v dv ds or d2s by dt2, all the three expression of tangential acceleration. And normal acceleration is given by v square by rho. This is v square by rho, right? And rho is the radius of curvature, which is denoted by, or which is expressed as ds by d psi. Okay, that is the derivative of arc length with respect to the angle psi. Now, from the first condition, according to the first condition, tangential acceleration is constant. So we first write tangential acceleration Ft. This is constant. Let it be lambda. This is constant. We say. Okay, and from here we can write this is dv dt, or we write this is dv dt, or we write v dv ds, v dv ds. This is the suitable form of tangential acceleration here. This is lambda. Okay, and from the second condition we get tangential velocity. Tangential velocity means Vt by normal acceleration. Normal acceleration means this Fn. This is also constant. We say this is mu, or we write this is mu. Okay. So we put the value of Vt, which is given by V. Okay. V by this is Fn. Fn means V square by rho. So this is V square by rho. This is mu. Okay. And we get from here, this is rho by V, this is mu, and we get V, this is equal to, or V mu, this is equal to rho. Okay. We name this relation as relation number 2 and this relation as relation number 1. This is the relation number 1 and this is relation number 2. Now from 1 or 1 imply we write V dV, this is lambda ds, and now integrate this relation, we get this is V dV, this is integration lambda ds, and we must put an integrating constant which is alpha. Okay, or we put alpha by 2 for simplicity. Now integrating we get V square by 2, this is lambda s plus alpha by 2, and getting the relation as V square, this is equal to 2 lambda s plus alpha. Okay, we get this relation by integrating relation number 1. Now we get from here, this is, here we write, this is V, this is root under 2 lambda s plus alpha. Okay. Now we put the value of V from here and getting the result as, this is V, so rho by mu, this is root under 2 lambda s plus alpha. And now we put the value of rho which is given by ds by d psi. So we get the relation ds by d psi. This is given by mu into root under 2 lambda s plus alpha. Okay, and from here we write this relation as ds by root under 2 lambda s plus alpha, and this is given by mu into d psi. Okay, again we integrate this relation and we put here another integrating constant which is beta, and the integration of this is given by 1 by 2 lambda into, this is 1 by root x type integration, so we get 2 lambda s plus alpha whole to the power minus half plus 1 by minus half plus 1. Okay, and the right side we get, this is mu psi plus beta. Okay, and from here we get the relation 2 into root under 2 lambda s plus alpha. This is given by 2 lambda, we multiply on the right side, we get 2 lambda into mu psi plus beta. Okay, now we squaring both sides, we get the relation as 4 into 2 lambda s plus alpha. This is 4 into lambda square into mu psi plus beta whole square. Right, 4 cancel out, and getting the relation as, this is 2 lambda psi, this is given by lambda square mu square psi square plus 2 mu beta lambda square psi plus beta square minus alpha. Okay, we write alpha on the right side. Then from this relation we can write the result as, sorry, this is not psi, this is s. We get s, this is equal to lambda square mu square by 2 lambda into psi square. Okay, and the second term is 2 mu beta by 2 lambda into psi, and the third term is beta square minus alpha by 2 lambda. Okay, now we put this value as capital A, this value as capital B, and this value as capital C. Then we get our required result. Okay, so final answer is given by S, this is equal to A psi square plus B psi plus C. Okay, where A is given by this, B is given by this, and C is given by this. These three are all constant. Okay, very simple but interesting problem from tangential and normal acceleration. Thank you for watching.